Hello students, welcome to our online open class. Now we are going to learn about the program design for cavity type parts. There are 5 operations for a product in a total, namely 5 machining tasks. Each operation follows these 6 steps: creating tools, creating the workpiece coordinate system, creating the blank, compiling the program, simulating machining, and optimizing the program. Now let's start with the first operation of a product. It is about creating rough machining of the contour. As for cavity machining, usually we do rough machining first and then finishing machining. The UG cavity milling is utilized in this operation. More importantly, we should pay attention to the cutting plane. The cut method includes area milling and contour milling. We should appropriately decide the cut area, starting point, and entry or reject option. In the parameter settings, we should check the cutting parameters, corner control, avoidance geometries. What's more, we should ensure that the floor stock and wall stock are within 0.5 mm. The programming steps are as follows. Enter the UG machining interface and open the Start Processing option. Select a cutter or create different types of cutters aligned with the product's technical requirements. This file can be named as D16R4, in which D16 is the cutter diameter and R4 shows its corner radius. Create a machining coordinate system, MCS. In this process, we should measure the basic dimensions of the part and then enter the geometry creation interface and create a MCS coordinate system. The coordinate system should be set on workpiece surface, which can be named arbitrarily. Create an operation. We use the cavity milling method. Adjust the boundary. Set the tool path. Simulate the machining. Please look at the skew operation for details. Next, we'll begin the skew operation for rough machining the cavity-like contour. First, click on the Modeling module. Let's start by analyzing the distance from the top of the spherical surface to this coordinate origin. Access the Distance Measurement tool. Select the spherical surface. Click OK in the dialog box. Then press Ctrl, Alt, and F buttons to switch to the front view and select this surface. Here, there's a height of 20 mm. Click OK. Switch back to the isometric view. Return to the Home tab. Navigate to the menu, access Edit, and then Move Object. Click on the Move Object command. Set the distance under Motion. Select Distance. Specify the vector director as upward movement. Set the distance to 20 mm. Check Move Original, ensuring the whole object moves downward by 20 mm. Select the geometry as the object to be moved. Then click OK. Now, the workpiece coordinate system is located on the upper surface of the geometric center. Once OK, enter the application module, find the processing module, and select 2D milling. Click OK. Next, click on Machine View, and then create tool. Our first tool is a 16mm tool named D16R4. Click OK and adjust the diameter to 16mm with a lower radius of 4mm. Click OK again. Proceed to create a second tool with a diameter of 8mm named D8R2. Click OK. Set the lower radius to 2mm and click OK. Now create a third tool, a ball end mill with a diameter of 6mm named Q6. Click OK. Set the ball diameters to 6mm and click OK. After creating the three tools, proceed to create a geometric entity. Enter Geometry View. Click Create Geometry and generate a Machine Coordinate System, MCS. Change the MCS name to A. And click OK with default parameters. Next, access Create Geometry again. Select Workpiece. Choose the previous created A geometry under Geometries. Rename it to B and click OK. Pick the To Be machined part. Then click OK. Specify the blank geometry. Locate bounding box and select the geometry. Move the bounding box upward by 1mm and click OK. Finally, click OK. Next, create a new operation by clicking on Create Process. Locate Surface Machining and choose Cavity Milling. Select the previously created 16mm tool and the B geometry specifying roughing as the operation type. Name this operation Contour Rough Machining Process. And click OK. Proceed to define the cutting area by clicking on Specify Cutting Area. And choose the method for selecting surfaces. Pick the cutting area by selecting all relevant entities. Hold down the Ctrl and Alt keys while pressing T to enter the top view. In this view, use the selection box to encompass all upper surfaces. Afterward, pick the surfaces that do not require machining and click OK. Switch to the side view. Choose Follow Part as the cutting mode and set the maximum step to 1mm for layered machining. Click on Cutting Parameters to adjust the settings. Opt for preferential milling with a cutting allowance of 0.5 mm and a blank allowance of 0.5 mm. Click OK. Click Non-Cutting Parameters. Choose Spiral Entry, Arc Entry. Maintain consistency for entry and exit and click OK. Then in feed rate and speed, set the spindle speed to 2000 and the feed rate to 700. Calculate and click OK. Generate the tool path. Find OK and click the 3D Dynamic Simulation by clicking Play. Enter into the simulation of the machining screen. In cavity milling, each cutting area's default starting point is the midpoint of some straight edge. For simple cavity parts, finish the bottom first, then the side. Considering the large machining allowance, use the milling method for rough machining. Cavity milling can use methods like following the perimeter, contour machining, parallel lines but not concentric circles. It is not suitable for direct wall planar machining. Speed up the simulation and once complete, click OK. Finally, click on the geometry, right-click to find post-processing. Select the corresponding post-processing file. Choose the metric or imperial and click OK. The machining program is now generated and can be modified and optimized according to the available equipment. The skill operation is now complete. In most cases, flat milling can be replaced by cavity milling. As a common method in mold machining, it's commonly used in rough machining of core cavities and complex surfaces. Machine the layer is usually set from the top of islands to the cavity bottom. Check and analyze the geometry machining. Establish the principles for setting up the coordinate system. Select the machining range. Set the tool path. Set the cutting layers. Set the cutting parameters. Set the parameters for non-cutting movement. Today we completed the first operation of program design for the cavity shape part on the UG software platform. During the programming process, we used the cavity milling method. Students can practice on their own based on the operation demonstration, check the cutting parameters, control corners, and avoidance geometries on your own according to the operation demonstration. Now, assuming that you are technicians, you can set parameters appropriately and optimize them in the program. Don't forget to apply this knowledge to other similar product program designs. Thank you for listening.